Welcome back. Today's topic is math review. This doesn't mean that I'm gonna teach math. It's more like I'm gonna tell you what kind of math we are gonna use. So you will go back to your textbook or notebook and you will refresh your memory by yourself. So let's get started thinking about this question. Why do you use math in the first place? Math or mathematical models? The reason is uh, it is accurate. Math is accurate. Uh, what I mean by that is natural languages are inaccurate, so we cannot use that because it allows lots of confusions. So, for example, we use this term a lot, but the what does it mean? A lot. If I say the same thing 5 times, does that mean I say the same thing a lot, or 10 times, or 100 times? So, by this term, a lot, you know, we can mean lots of different things. And also, math is easier to understand. Some people think that math is difficult. Of course, math is difficult, but other things are more difficult, I think. So what I mean is, um, we want to minimize confusion in communication, and because math is accurate, it minimizes confusion. We can avoid confusions. So some people think that sociology is easier, or some books written in natural language is easier and easier to understand, but we have to distinguish understanding from feeling like understanding. So you may feel like you understand a book, but uh, because lots of things are unclear in a book, uh, maybe you don't really understand it. But if something is written in mathematical language, even a computer can understand uh, what that mean by uh, what that mathematical code means. So yeah, that's the reason why we use mathematical models. And also, math is logical, which means there is no magic. What I mean by this is you probably remember uh, some politicians claim that I'm gonna spend more. I mean, the government will spend more for the economy, but at the same time, uh, they want to reduce the tax rate. But simply that's not possible. If you want to spend more, you have to earn more. So we don't want to allow such a magic. So we want to be logical because the world is logical. So that's the reason, these are the reasons why we use math. Okay, so that's the motivation. Then, what kind of math do you use? That's the topic that I want to talk about today. Uh, so we are not going to use geometry for sure. We are not going to use, um, I don't know, combinatorial. We are going to use just two uh, parts of math, two fields of math, two method, two mathematical methods. One is probability theory, the other is constraint optimization. You don't even need to know matrix algebra. All you need to know is probability theory and um, constraint optimization. So just to take this course, just go back to your textbook or notebook and review what you learned in math classes. So probability theory. So why? Why do we need probability theory? Because the world is full of uncertainties and we have to think about them and somehow we have to deal with them. So we need language to describe such uncertainties and people's responses to such uncertainties. And probability theory provides a language for that purpose. So how exactly do we use it? We'll assume that people maximize their expected utility. For example, your utility is 100 in state A and 50 in state B. And let's say states A and B are equally likely, so state A can happen with probability half, and state B can take place with probability half, half and half, equally likely. Then your expected utility is your utility in state A, which is 100, times half, which is the probability that state A is taking place, and your utility in state B, which is 50, times half, which is the probability that state B is realized. Then your expected utility is 75. So we are going to use this idea of expectation and probability, etc., in this way. So, but of course, you have to need to know more than this, So, I recommend you to go and review your statistics notebooks and textbooks. And another thing is constraint optimization. So why do you use constraint optimization? Two reasons. One is positive, the other is normative. So positive means we want to describe the world using this mathematical concept, constraint optimization. And it is useful because we are going to assume that people are maximizing their expected utility, given some constraints. And if you think about this seriously, then you may feel like, okay, in economics classes, we often assume that people are maximizing their utility, but in reality, nobody is actually maximizing any function. Even there are people who have no idea about maximization or any kind of math. So then, what's the point of talking about this maximization? But I want to defend this assumption and the practices in economics by this. People want to improve their situation, and they tried different things. And if they are satisfied with an alternative, then they will keep choosing that better alternative. And these small changes can stack up, and after a while of this process of probing, searching, people may end up with very high satisfaction or higher utility. So maybe in one point of time they are not maximizing their utility, but over time they make small changes. They make small changes in the direction to improve their situation, improve their personal satisfaction or utility, and such changes add up to something similar to maximized utility. So that's one reason why we consider this math concept, constraint optimization. So we want to describe the world, people's behavior, and we believe that people want to improve their situation, and after a while, after making small changes for a while, we'll observe people's behavior which is somewhat similar to optimal behavior. So that's the reason why we use this constraint optimization tool And the second reason is normative. Uh, in contract theory, we want to think about a better design of contract or best design of contract, and we want to figure out what is best, how we can improve our society, how we can improve our institutions. So, and this mathematical tool can be used, it must be used to answer such questions. So we want to figure out the best strategy in a given situation, or in our context, in our class, this would mean the best contract. So two reasons, positive, normative. These are the reasons why we are using constraint optimization. Then how do we optimize given constraints? Probably you have done this many times in other economics classes, so you probably know what I mean by this: to equalize the marginal benefit to the marginal cost, right? So to maximize something, maximize utility or maximize some objective, you equalize the marginal benefit and marginal cost. Or you can rephrase it like this: we set the marginal utility or set the marginal net benefit to 0. So if the marginal utility is 0, that means you are maximizing your utility. So there are lots of marginals. So why do we have so many marginals? What do we mean by this marginals? So marginal means small, incremental, etc. So let's imagine a bathtub, and you are about to take a bath, and of course, to take a bath you need water with the right temperature. So then the question is, how do you find the right temperature? The best temperature, the optimal temperature. Let's say the water is too cold, then you turn the water to the hotter side. Then maybe the water becomes too hot, then you change it to the colder side. Then, when you change the temperature, you don't change it drastically. You change little by little. You increase temperature a little bit, and you feel like, okay, this is a little bit better. Then maybe I want to increase temperature a little bit more, and you feel a little bit better, and you keep doing it until you feel, let's say, nothing. And if you keep increasing the temperature, then you will feel worse because the water is too hot. So that's not what you want. You want the temperature to be optimal, at which case your marginal utility will be 0. Marginal utility of increasing temperature will be 0. So you keep increasing temperature until the marginal utility of increasing temperature is 0. So that's basically the idea. So we use differentiation a lot, and you differentiate the utility function or the objective function, then you get marginal utility, which is the incremental change in utility. If the incremental change in utility becomes 0, that means your utility is basically maximized. So this is what we are gonna use a lot in our class. So go and review your math notebook and textbooks, and make sure that you understand how to use Lagrangian. I was really surprised to find out that many students, many junior and senior students, didn't know how to solve Lagrangian, didn't know how to set up Lagrangian. So that's not ideal, that's not really good. So go back to your notebook and textbooks and just review Lagrangian and other techniques. So yeah, that's what I want to recommend. That's basically a homework, so you have to do it. And before we call it a day, I just want to uh, refresh your memory about this constraint optimization, and I want to let's say I want to plant a concept about constraint optimization, or I want to give you a picture. I want you to have this picture in your mind whenever you do constraint optimization. Um, so our objective function, the 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 function that we want to maximize, is f of x. So f of x is our objective function. Let's say it's our utility function, and in this problem we have just one constraint, which is x should be greater than x0. Okay, so we have this one constraint and we want to maximize f of x. Then what is the optimal point? Answer is B. So the optimal point is B, even if we have this constraint x is greater than or equal to 0, x is greater than or equal to x0. That constraint is not important because this point B is inside this constraint set. So this constraint is meaningless. In other words, this constraint is not binding, it's not important. So the solution of constraint maximization is the same with the solution of unconstrained maximization, which is B. So solution is B. But what about this question? Now the constraint is different. X is greater than or equal to x1. With this constraint, is B still the maximum point? The answer is no. The maximum is C, because B is outside of the constraint set. We cannot choose B. The constraint doesn't allow it. So what is the maximum? C. C is the maximum. So we want to go to B, point B, as much as possible, but the constraint is not allowing going further to B. So C is the point where this objective is maximized given the constraint. Okay, so let's think about this. We have two constraints. One is x should be greater than or equal to x0. The other is x should be greater than or equal to x1. So we have two constraints, and some of you have figured out that not all constraints are important. Only one constraint is important. Which one? Okay, the second one is important. The first one is meaningless. And in our class, we are gonna say that the first constraint is not binding, and the second constraint is binding. And binding constraint is important constraint. So we can ignore the first constraint, because if x is greater than, sorry about that, if x is greater than x0, if x is greater than x1, then it must be greater than x0. So if the second constraint is satisfied, then the first constraint is automatically satisfied. So we can ignore the first constraint. We can focus on the binding constraint. And again, the solution is C. The maximum point is C. Finally, what about this? x should be smaller than or equal to x0, and x should be at the same time x should be larger than x1. What is the solution in this case? The answer is none. Now there is no x which satisfy these two constraints at the same time. So the constraint set is empty set. So there is no maximum. There is no maximizer in x. So what I wanted to emphasize is this: when there are multiple constraints, and in our class we are gonna consider many maximization problem with multiple constraints. We need to figure out which ones are binding and which ones are not. So we have, let's say, monetary constraint, we have time constraint, we have probably many other constraints, and we have to figure out which one is important and which one is not. Let's say monetary constraint is important and time constraint is not important, then earning more money is more valuable than earning more time, right? If money again, let me repeat. Let's say money constraint is binding and time constraint is not binding, then relaxing money constraint is more important than relaxing time constraint. And if time constraint is more important, let's say you're working and you earn enough money, but you don't have time to enjoy your life, then earning more money is not so important. Anyway, you don't have time to spend your money. Instead, you have to figure out how to reduce your work and how to find more free time, right? So figuring out which constraint is binding and which constraint is not is important, not only in our class but also in our life. So then you may ask, how can we figure out which one is binding, which one is not? And we'll see, but intuitively you probably have an idea. But for now, just remember this: not all constraints are important. Some constraints are important. Binding constraints are important. Some are not binding. They are not important. So for example, if you are poor, if you don't have much money, you don't work, you just get money from your parents, let's say, then monetary constraint will be binding. You want to have more delicious food, you want to spend you want to drink more, but you don't have money. That means money constraint is binding. Then to improve your utility, you need to earn more money. You need to figure out the way to increase your budget. But if you're busy, let's say you are working, then time constraint may be more important. You are working, I don't know, many part-time jobs, 5 part-time jobs, you don't have time to enjoy your life, you have enough money, then what you have to consider is to reduce your work, right? To find time to enjoy your life. So depending on which constraint is binding, your optimal behavior, your best strategy is different. So we have to figure out which constraint is binding. Okay, so that's what I want to talk about today. That's all, and let's call it a day. And don't forget to review the techniques that we'll use, probability theory and constraint optimization. Go back to your notebooks, textbooks and review those. Alright? Thank you. Bye.